subtraction as takeaway. You don't need to write the word problem, but our title is subtraction as takeaway. So this is how we are used to thinking about subtraction. When we have something, a total, an amount, why our title's on the board, please, and then we're taking away some of that. You might be giving away something, you might have eaten something, you might have just lost something. All of those could be an example where you would be subtracting because it's been taken away. So let's look at this example. Not while I'm speaking, please. Let's look at this example. It says Coco the clown was making balloon animals at a birthday party. He made 22 balloon animals. At the party, he gave away 17 balloon animals. How many balloon animals does he have now? What am I counting in this problem? What am I counting in this problem? Penelope? I'm counting balloon animals. So my answer sentence is going to say, he has blank balloon animals. There's my answer sentence. He has blank balloon animals. Penelope told us that we're counting balloon animals. Underneath that, I'm going to go ahead and draw a bar. That bar is going to show all the balloon animals that Coco made. Think of that like the bag of balloon animals. How many balloon animals did Coco the clown make? Oh. It's not a trick question. It's in our problem. Colby? He made 22. So I'm going to write the number 22 in that bar. So far, so good. Yes? All right. Then what happened? We've got our bag of 22 balloon animals, and we wrote 22 in the bar. Then what happened? Julian?
He gave away
17 balloon animals. So what I'm going to do is right underneath that, Julian, I'm going to draw another bar. But I'm going to make this bar a little bit shorter. Does anyone have an idea why I made that bar a little bit shorter? Avery, why did I make that bar a little bit shorter?
Because it's not, if it was just the right size of that bar, then it would be the same number. But if it's less, then that means it's less than the big number that you have.
Love that. So I'm going to kind of restate what Avery just said. Avery, double check I'm saying this right. Avery said if I made my bar the exact same size, then that would tell me they have the same value. They'd be worth the same. Remember when we did those lines of equality? But because one of them is a little bit shorter, are they equal?
No.
No, one is less. So this is going to be the number that he gave away. He gave away 17.
Which is 15.
Now we have this little space from 17 to the end of the 20 bar. Do you see this space right here?
Yeah.
This is a ghost space, so I'm going to make like a dotted line. My ghost space. If I had 22, which was my total, and I got rid of this part, I'm going to end up with that part. Does that make sense?
Yeah.
If I think about it opposite, and I think, okay, I had 17 and then I got some more, then I would have this total. Above that 22, or in the same box, let's write a W. What do you think that W means? Paxton? Whole. Next to 17, let's write a P. What do you think that P means? Marley?
Part.
Part. And then our ghost box is going to get a P too. We've got a whole part.
We have to find out what that's called.
You have to figure out what that other part is. If I remember part, whole, it's part plus part equals my whole. So I'm going to use those pieces to figure it out. So I have 17 plus box equals 22. If I use subtraction, kind of like division, I have to start with all the things. That means I have to start with my total. It's not always the bigger number. I have to start with the total. In third grade land, it is usually the bigger number, but in mathematics, it's not always the bigger number. So when I'm going to make a subtraction equation, I'm going to start with my total, which is 22. And then he gave away some, or a part, which is 17. And then that equals my box. Paxton, we're writing, please. Either of those equations will work. Either of those equations will work. All right, now we're going to do some actual subtraction. Because we're going to use our equation 22 minus 17 equals box. To do this, I'm going to use some base 10 drawing. Just a reminder what base 10 drawings are. Our base 10 pieces are in our math kit. We have the little bits that equal 1, the tens rods that are equal to 10, and then 100s flat that's equal to 100. You know what I'm talking about? Yeah? Okay. So I'm going to start with the number 22 because that's how many balloon animals he has. How do I show the number 22 with base 10 pieces? I should see everybody's hand. This is not a trick question. How do I build the number 22 with base 10 pieces? Samaya? Two tens. So we're going to draw 2 sticks. Those are going to represent my 2 tens. Cool, no thank you. I can't hear you. What?
Pardon this interruption.
Go ahead. I can't hear you. Yes, we're making 22, yep. So far we've got 2 tens. 2 ones. Now, you might not have used this strategy before, but I kind of like it. Next to this, draw a circle. Cool.
Be really big.
What happened? All right, pretend that's a circle. Inside that circle is where we are going to put 17. 17 is going in there. That's kind of like saying, okay, he's made 22 animals, and now he's getting ready to give away 17. In order to do that, what do I need to do?
Take away 17.
Marley, what do you think?
We need to find the distance between 22 and 17.
So I could use my number line and find the distance. But today we're going to think about it as takeaway.
Then you could use your fingers and say 22 and like take away 17.
So we're going to use our base 10 pieces to do that. In order to make 17, How many ones do I need?
But your fingers only work for
Emma,
7.
I need 7. I'm going to go ahead and take these ones that I have, and I'm going to pull them over. Oops. I'm going to pull them over into my box. You can draw an arrow. If you want to, that's fine. So I put my ones in my 17. Is that enough? 1?
No.
You need.
No. 2 10.
So right now, I only have 2 ones, but you already told me that I need 7 ones to make the number 17. Where am I going to get more ones? Because right now, all I have are 2 10s. That's it. Owen, what you think?
So what I would do here is I would see what 2 minus 7 to find out if we need to subtract.
So 2 minus 7 is going to be negative 5.
-5.
Yes. If I have 2 things and I owe you 7 things, I can give you 2 of those things and I'm in the negative. So that doesn't really help me. I don't really want to be playing with a negative number. Archer, what do you think?
I'll play with
You're
it.
gonna take a 10 and you're gonna make it go into 1. And then you would put how many ones you need into that.
Yes. So what Archer is saying is he's going to break apart that 10 into some ones. How many ones do you get when you break up a 10? 10 ones. We either call that breakup or we call it ungroup. So underneath this, I want you to write ungroup a 10. Ungroup a 10. Now when I ungroup a 10, I have to ungroup the whole thing. I can't leave some of it pieced together. So I'm going to erase my 10, and I'm now going to do 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My value hasn't changed. It just looks a little different. Now, instead of having 2 10s, or if we're writing, I have 1 10 and 10 ones. It's still worth the same amount. It just looks a little different. When I did that, do I have enough ones to make my 17?
Yes.
Yes, I can start pulling over some more ones. So far I have 2 ones. Now I have, all right, I'll take both of you at the same time, that's fine.
Now I have
Come on now.
17.
There's 4. I'm just going to erase
You can do that.
and redraw. I'm struggling to drag. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go.
Should we put 9?
I'm only going to put 7 ones because remember I'm building the number 17 and you told me that there was only 7 ones needed in 17.
Take 2 away.
I thought you had 5.
No, I didn't have 5. That's okay. But I still don't have the number 17. Did you see that?
So we
Right now, inside my circle, I only have 7. So what do I need to do now? I only have 7 inside my circle.
We have 3 left. But we have 3 left.
Jordan, what do you think I should do?
you take a 10 and put it in.
Yeah, I go ahead and take my 10 and put it in my circle. So now my circle has 17. And I took that 17 straight from 22. Does that 22 still look like 22?
No.
No.
It looks
And
like
it shouldn't look like 22 because you just took 17 out of it. How much is left of my 22? How much is left? Lydia?
4.
Not 4.
The 3.
Connor, sit up. Marley?
5.
5. There's 5 left. So I started with 22. I took away 17 and put them over here. And I have 5 left. Does that make sense?
Yes.
Yes? Kind of.
Yeah.
Kind of, sort of.
Yeah.
Alright, we're going to keep using this strategy. Whoops, went too far. Go ahead and write this equation. You can do it on the next blank page if you need to. If you have space, you can do it under. We have the equation 712 take away 596. We know that we're going to start with 712. That's what I'm starting with.
Bigger number.
No, because it's in the whole position.
Oh, yeah.
If it's in this first position, that tells me that's the total, not because it's the bigger number. Go ahead and start drawing 712 in your base 10 pieces. Hundreds, tens, and ones. You probably drew 700s. 110 and 2 ones. Give me a Me Too signal if that's what you drew on your paper. Perfect. We're taking away something from that. To the side, draw our circle. What am I taking away?
It's like a black hole.
Kind of.
And it sucks up.
What am I taking away from 712? Addison? 596. What do you want to build 596 with first? We could move our hundreds, we could move some tens, we could move some ones. I don't care. What you want to move first? Ava?
500.
All right, Ava wants to move 500. I'm going to cross out 500. 1, 2, 3, 4, 5, because they have now appeared over here. That's where they went.
It's a black hole that.
They were in 712, and we took them to build the number 596. That's where it went. So far, so good, yes? No. Now what do we want to move? 10, 1s. Paxton, what are you thinking? 10s. All right, we have 110, right?
So bring 110.
So I'm going to scoot you over. There you go. But Paxton, is that the number of 10s that I need?
No.
Yay.
9. So
I need 9 10s. But Paxton, we only had 110. So what am I going to do? Take apart a 100. It's time to ungroup a 100. So what I'm going to do is I'm going to X out my 100, but then still in the 712, because I'm just redrawing it really, I'm going to draw 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Raise your hand to tell me, why did I X out 100 and then draw 10 10s?
I don't know.
I crossed out 100, but then redrew them as 10 10s. Art, why did I do that?
Because 100 is worth 10.
Whoa, did you hear that, genius? Say it again, Art, a little louder from the front to the back.
Because 100 is worth 10.
100 is worth 10 10s. Now, Paxton, I already have 110. How many more do I need over there? 8. Cross them out. 1, 2, 3, 4, 5, 6, 7, 8. That means you're got 9. Well, we already took 1 away. We already moved the 10 that we had. So we only have to take 8. Alright? Just to double check, let's make sure I'm building the right number. I've got 100, 200, 200, 300, 400, 500, 510, 520, 530, 540, 550, 560, 570, 580, 590. Perfect.
But
Now I need some ones.
you need to score me like
Alright, I'm going to go ahead and cross out those 2 ones that I got because I know they got to go over. Goodbye, goodbye. Hello, hello. Is that enough ones though?
No.
No.
We took one, so you took
I still need some ones, but it doesn't look like I have any ones. Notice I said it doesn't look like I have any ones. Do I still have ones?
Yes,
Yes, I do, but they're hiding. Well, where are those ones hiding?
Inside the 10.
They could be hiding inside 100, but that means you would have to draw 100 ones. Do you want to do that?
No.
So Paul is correct. We're going to go ahead and ungroup a 10. So cross out a 10 here. And we're going to draw 10 ones. Why did I just draw 10 ones? I crossed out a 10, but then I drew 10 ones. Callie, why did I do that?
Because 1 is equal to 10.
Yeah, our 10 ones is worth the same as 1 10. Does it look the same? No, they look a little different. Smell a little different. Taste a little different.
They do?
They taste. Not the commutative property. It is just equality. That's what you're looking for. In fact, you can even say, Bowen, that they are equivalent. That means that they might look a little different, but they have that same value. They're equivalent. But I still need some ones, because I only have 2 over here. How many more ones do I need to scooch on over to that party? Accent? Or cross them out. Goodbye. 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 Hello. 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 All right. That's 712. That looks crazy. It looks crazy. But I know we didn't use all 712. There's some left over. And I know because if I used it all, it would say 712 minus 712. Was it 712 minus 712?
No.
No. So I know there's going to be some left over. Sit up.
Black hole away.
What do we have left over? What survived in the 712 from the 596?
From the black hole.
From the black hole. Arik, what survived?
A 100, a 110,
A 100, a 110, and 6 ones. If I were to write that as a number, what would that be worth? Archer?
160.
160. Does this strategy kind of take a little bit of
Yes.
I love those. Awesome. I'm going to have you try this next one on your own. I'm going to come around and visit to make sure that we're building it correctly. Go ahead and put it on the next blank page. That way I don't get confused with another problem in your notebook. The equation that you're going to be solving is 928. Take away 312. So go ahead and write that equation on the next blank page. I make sure you put that in the pages. Those are all pages you can be writing on.
So maximum rate our black hole complete is 312.
Yep, maximum black hole rate is 312. It's sucking 312 from the soul of 928. It's not going to eat the whole thing because I know if it ate the whole thing, it would say 928 minus 928. Go ahead and start trying to figure that out. I will come around and see what we're doing.